Bismillahirrahmanirrahim. Welcome to BeingGuruElectrical channel. This is Majib Raza video with a new topic, PLC architecture, and this is the series of PLC programming course, class 3. Before going to start the PLC architecture, subscribe the channel and turn on the notification so you will receive the latest updates of the channel. So now moving towards the today topic, PLC architecture. This is the basic architecture of the PLC. In the basic architecture, we have memory, we have input card, we have output card, and we have central processing unit, CPU. Input is connected to the real world and output is connected to the real world. And we have at the input we have analog input or digital input. It may be switches, it may be sensor. Output is normally the load, and it may be digital or it may be analog. Now in the memory we have a program which is a ladder logic program, and the CPU. There are three types of buses. One is address bus, one is data bus, and the third one is control bus. The address bus is used to select the specific memory location in the memory. If the CPU needs some data from the memory, so this address bus select that memory location or that memory register, and through this data bus the CPU take the data from the selected address. And same, if we need some status of the input, so this address bus select the specific input, and it can be saved to the memory, and from the memory the CPU can take the status. So this is unidirectional. Address bus is unidirectional. Only the CPU tells which memory is to select to get the data or write the data, or which input is to select to get the data, or which output is to select to put the data. So the data bus is only transferring or reading the data or writing the data into the memory. The control bus is serve as the communication channel between input, output, memory, and CPU. This architecture is, if you see, it's more similar to the computer architecture. Next we have PLC system. In PLC system we have four major parts. One is the power supply, which is used to power the CPU. One is input module connected to the input switches, and maybe the sensors. Sensor may be analog or digital. Output is module is connected to load, and we have central processing unit which have the memory. Memory is subdivided into two types. One is program memory and one is data memory. Program memory is the one in which we put our ladder logic. This is the programming device. We make a program in the software in the programming device and then download the program into the PLC. So this is the program memory where our PLC program is stored. Now the data memory is the one in which we have the status of the timer, counters, input image, output image, etc. So this is about the PLC system. Now the memory map. If you see the memory map of the PLC, this is divided into three parts. One is the data table, one is user program, and one is housekeeping memory. Data table consists of input data register and output data registers, and also the input relays and timers, counters are stored in the data table. User program is the one in which we put our ladder logic or user defined program. Housekeeping memory is the one in which come with the PLC inbuilt, and it cannot be changed by the user. So this is about the memory map. Now program files. If you see the program files, we have system functions which are inbuilt in the PLC, reserved which are inbuilt in the PLC, and user program and subroutine program. These two we can program. We can make a ladder logic for this. This you can see this is the ladder logic program. So this can put inside the user program and subroutine program. The major part of the PLC memory consists of user program and subroutine program. Now we have data files. Data files, as we discussed, we have output image. Output image means the output status is same. The input image is storing into the input images. Like all our input status are coming to the input image. Status consists of status of the PLC. It includes run state, stop state, fault state, bit timer, counter, control. This we will discuss in the later in detail. Data files, this we will discuss in detail when we go to the program in the software. But anyhow, this is 0:2 is the data register. This 00 is and 01 are defined for the built-in memory. You cannot change this output. Only our memory start from 0:2, 0:3, 0:4, 0:5. So this we will discuss later in the real-time software. Input table file operation. We have the input module which is connected to a switch, and the switch is open, and this status is reflecting on the memory location which is taken from this data table. From data table we have one data register, and this one bit is representing the state of this input of the input module. So this switch is open, so this is 0. If this is closed, it will switch to 1. See, this switch is closed, now this is 1. So the processor is continuously checking the status of the input, and as a result of this change in the input, it updates the data registers. So this we will discuss later in the when we discuss the program cycle of the PLC. Same for the output. We have output module connected to a load, and we have one and this output is connected to this specific bit. So this is 0, so the output is off. If this bit is changed to 1, the load will turn on. See, in this case also processor continuously activate or deactivate output status according to the output image table file status. This is output image. So this is all about PLC architecture. In the next lecture we will study the PLC program cycle. Till now, subscribe the channel, subscribe and turn on the notification so you will receive the notification timely. Thank you.